This is the Open HPI course Linked Data Engineering, and this is Lecture 2, RDF and RDFS. In this part of the course, we want to talk about RDF data structures. Okay, so let's start again. RDF, we know, is the information exchange layer, the resource description framework within the semantic web technology stack. So, first data structure that we learn about are so-called RDF lists, and they are usually used as a general data structure to enumerate any resources or literals, but they don't contain new meaning. They are only some kind of shortcut for writing something without additional, as you say, semantic expressivity. So some people call them syntactic sugar because, yeah, it's some nice abbreviation, nothing else. You will see that. And there we distinguish two different types of lists. We have so-called open lists, these are the containers, and we have closed lists, which are the collections. What's the difference? In an open list, you can do any extension you want at any point in time, so you can extend these lists. In a collection, this is a closed list, which means there is no extension possible. This, of course, is some kind of a semantic difference. So, first containers, then collections. Let's have a look. First one is the so-called open list. It's the RDF container. Now this looks, of course, rather complicated. So we will see that it's much easier than you think. What we want to express here is that we define something which is the solar system, and then we define the planets, and the planets are defined as an RDF container. And the RDF container is a blank node here, which contains then the single planets. The nice thing is then you can refer to all the planets by referring to exactly that container. And the container contains now several items, and the items are connected, as you see here, via a property which is called RDF _1, RDF _2, _3, and so on and so on and so on. So you can go to infinity. The point is, of course, there is only a limited number of planets in the solar system, but nevertheless, we end here with Saturn. But if you want to add another planet, for example, Neptune or Uranus, you are free to do that. So you see here, you can put in all the planets to the solar system to this container. There is another interesting fact in that graph that is below here, that you see here. Yeah, and it says that this container has a specific type. It has the type RDF sec, which stands for sequential. So you can define different types of containers. RDF provides three types of containers. First one is the RDF bag. This is a container where the order of the set of things that you put together in a container does not matter. So for an unordered set, use the type bag. If the order of the set is somehow of significance, you can order it, of course, according to the numbers you see here with _1, _2, and so on and so on. Here for the planets, for example, it's important to put them in the right order, starting from the sun, for example. And here you have a sequential container. So you define the container to be type of RDF sec, which means sequential. And you have a third possibility. This is an alternative, RDF alt, which means you define in a container a collection of things from which you can choose one. So all these things that are put in the container, they are alternatives. You can choose simply one. Which one doesn't matter. So this would be then an alternative container. So these three possibilities are given within RDF. Okay, so you might be right to say this is a complicated structure. Let's have a look at the turtle representation of that. So this now is the turtle representation, as you might think. So exactly like the graph given here, we define this container as a blank node. Here it's a nested, anonymous blank node. And this blank node then contains all these constituents of the RDF container, which are the planets, RDF sub 1, it's Mercury, RDF sub 2, Venus, RDF sub 3, it's Earth, and so on and so on. And one new thing for further abbreviation is shown here. That has nothing to do especially with the container. It can be used in RDF anywhere. If you are tired of writing RDF type, Turtle provides you the possibility to abbreviate RDF type with a simple A, which means something like I define a subject which is A, and then comes the class which it belongs to. So RDF type can further be abbreviated with A, as you see here. So this is the RDF container. If I want to include simply another planet, then I simply would write, of course, then RDF _7, and then I could add Uranus, for example. So let's have a look at the other possibility that you have. These are the so-called RDF collections, which are closed lists. So you might think, oh, this looks even more complicated, and you are right by that, because a collection is ordered like a linked list. So the programmers among you might recognize this, because a linked list, you know, this kind of data structure, is always structured in something which is ahead of the list and the entire rest of the list. And this is a recursive definition because the tail here, the rest of the list, also again consists out of a head and all the rest, which is then the tail. So these kind of data structures, linked lists, are also basic building blocks in so-called functional programming languages, logic programming languages like Lisp, for example, or Haskell. There you are using exactly these kind of lists. And of course, you know, RDF is a knowledge representation. And for legacy reasons, for example, one came up with the idea, yeah, of course, let's provide a collection, a list, something which is built according to the means or to the rules of these legacy logic-based programming languages. So RDF collection is based on the principle that a recursive defined list is constituted of a head and a tail. And the tail again then is also consists of a head and a tail, and so on and so on and so on. And the last element to close the list then is the null element. So you see this here. This is RDF nil. It's below there. This closes the list in the end. Okay, as I told you, for legacy reasons and to define something which cannot be further extended. So it's a closed list. Yeah, so if I write this according to the rules in Turtle, it looks, of course, even more complicated. Simply because I have here several blank nodes, and they are all nested in this structure as you see here. So I define my solar system, and it has planets, and I start with the first square bracket, and then in the first square bracket I say, okay, the first list element here is Mercury, and then comes the rest, and the rest is also expressed as a blank node. So again, I open a square bracket, and so on, and so on, and so on, until I finally close this and say, pardon me, RDF rest is RDF nil, which closes the RDF collection. Yeah, and of course, you know, Turtle somehow was about abbreviating things. So this is way too complicated, way too long. Therefore, the designers of Turtle, they have given us this nice representation of RDF collection. So instead of the square brackets that you are using for the blank nodes, to define an RDF collection, you simply use parentheses or round brackets. And then you write all the constituents, all the parts of the collection as a single list, which is separated simply by blank, of URIs, which are simply only the URIs of all the objects that are contained in that collection. And then you close your parentheses, you make a period, and that's it. And this is a rather easy way to define an RDF collection. So these are the two main data structures or data aggregations that you have in RDF. You have on the one hand the so-called RDF containers, open lists, which are extensible, and you have the closed lists, which are these RDF collections. And in the next part of the lecture, we will show you how to make statements about statements, to be able to represent something like this interesting assumption here, where Sherlock Holmes says, "My dear Watson, I suppose that it was the gardener who killed the butler.